Hi, welcome back. I'm doing a walkthrough of the Budget-Beater Electrathon car. If you haven't seen the intro video, you might want to back up and watch that one, kind of give you a bit of an overview of what the point of this project was and how it worked out, and also how you can perhaps have it donated to your organization if you're interested in starting an Electrathon team, because I'm not planning on keeping it. We're going to talk first about the chassis, the framework. It is made out of primarily half-inch conduit, straight from Home Depot. There's probably 6 pieces represented here. There's one piece of 3/4 inch, which is the roll bar and the rear legs that go down to the rear wheel. Those were kind of high stress areas. Oh, I suppose this crossbar here, because it's right where the driver sits. So I tried to strengthen a few key areas. Again, this was done without any welding. Basically, it is this. It is the conduit hammered flat and then rolled around and then bolted through with one rivet in it to keep it from being able to slide down the length of the tube. Because these joints pretty much only work perpendicular, I had to do kind of a parallelogram with the top rail and the bottom rail. I had to run parallel to each other so I could have these perpendicular. On most of my cars, I have it tapered down kind of like a wedge. Gives me a smaller nose area anyway. Couldn't do it with this one because of that. The diagonal pieces here, I tried to get some triangulation in to kind of stiffen it up some, and those just actually tied to where the bolts come through on the back side. I used longer bolts and then ran down that way to the longer bolt down here, up here, down there. These joints here, I used larger bolts on because I also attached the seat belt at that location. I used a through bolt here, carriage head bolt, so it's smooth on the back side here so you don't catch your shoulder on it and tear yourself up, which is why there's a nut visible on the outside. The top and bottom tubes are all identical to each other, or as close as I could make them. If you're going to tackle something like this, the easiest thing to do, first you mark your tubing with a line that runs straight down so you make sure you stay in the same plane on all of your bends. Otherwise you end up with some very strange geometry. Bend 1, make a mark as to where your bends are. Bend one tube in its complete form, and then go bend the other ones just like it using your marks. Then you can compare one to the other. That way you have all of them made the same. That's what I did. It made it easier. They're probably not all perfectly identical, but it was the best I could do. It seemed to work out okay too. If you're an 1/8 of an inch off here or there on this thing, I mean, it's not a space shuttle. It can be forgiving on that front. But the joints seem to work out pretty well. It seemed plenty strong. We carried the thing around, lifting it at the nose and at the back, and we didn't get a lot of flex to it. It seemed to hold its shape pretty well. It didn't do any weird sagging or anything during the course of the 3 races that we ran. It was a lot of work, and your design options are somewhat limited by this type of connection, but it is an option. Welding is, I'm going to say it's stronger, it's probably faster. If you know how to do it, it's less work. But if you straight up don't have a welder and aren't allowed to use one, if you're in a school situation and insurance or whatever won't let you do it, this is a viable option. It passed tech inspection. Of course, that's going to be up to the decision of your particular tech inspectors at your races, but I don't see why it wouldn't pass. It passed for this one. It seemed to work out. This is not going to be a tutorial. I'm not going to teach you how to do this. This is just representative of what can be done. use your own dimensions for things, fit yourself or your students or whoever is going to be in it. This one fit me. It fit the guys I got to drive it for me. I never actually raced this car. I was racing my other car, and I took volunteers to do this one. It worked out pretty well, but that's what it is. If we come back here, this piece here, as I said, nothing was welded, everything is bolted. Let's see if I can get where you can see that. This piece here, the insert for the wheels, started out as a piece of 1/4-inch aluminum. I cut it to shape on a bandsaw. That's why I went with aluminum instead of steel, because I didn't want to try to cut the whole thing with an angle grinder. Cut it with a bandsaw, just kind of broke the edges off, filed with a file so they were smooth. Inserted them into the tubes here, which were partially flattened, and then just drilled through and bolted them. And it seems to work out fine. I didn't have any problem with it. It held up fine. The track was not particularly smooth, so it had to take some impacts. There's no suspension on this thing, so this probably took a fair amount of beating, and it held up fine. Again, on the whole, I think this is a viable option if you do not have access to a welder. It seemed to work out okay. All right, on to the next thing. The front axle, and yes, the front axle is actually mounted on a piece of 2x6. I guess I'll talk about the 2x6 first. The reason I did this, the axle needs to have a certain amount of caster to it to allow the wheel to self-center after a turn, to make it so it's not real twitchy. I shot for 15 degrees, it worked out fine, but it's hard to set. If you're not going to weld, how are you going to set a square tube to 15 degrees and still support it? Would seem like the easiest way to go. I put this on a table saw with the blade set to a 15-degree angle, and we ripped down it. It is screwed, 2 screws through this support here, matching on the other side. 1 screw up from the bottom up into the 2x6, and then these 3 here are 5/16 carriage bolts that pass all the way up through the belly pan, all the way up through, with nuts on the top. It's kind of a questionable part of this thing in my estimation, but it worked, and it worked well. The annoying thing is you have to kind of get your feet over that and ride with your knees sitting above this. It's not the most uncomfortable thing, but it could be better. But again, in a no-weld build, you know, how else are you going to have a single beam axle supported the right way so you don't have your car 6-7 inches off the ground? Because of course a lower center of gravity is more stable when you're trying to run at speed and take high speed corners, or medium speed corners anyway. So the axle is 1.25 mild steel tubing, 1/16 wall, straight from Home Depot, 3 feet long. What I did on the ends was, there's bushings here. I cut a piece of the 1/2-inch conduit just the right length that it would kind of tap in there, so it's kind of a pinch fit, because with all the weight on this thing, it's all on the bottom, and I didn't want it to cave this wall up in and cause everything to get deformed. So by putting this here, it helps transfer some of that load up to the top rail. Well, then when you put the spindle on, that load gets transferred to the top of the spindle as well. So the whole thing becomes a lot stronger for having an insert. It seemed like the obvious choice. It worked out pretty well. I have no complaints. The oddness of having wood, lumber, in the construction kind of worked out when it came to the steering, though. The steering if you may recognize that, is part of a Razor scooter. I had it laying around. However, I did assign it a $5 value because you can go to almost any thrift store or Goodwill or whatever, yard sale, and you can pick them up for a couple of bucks. So I gave this one a $5 value. I took the entire headstock off and I screwed it straight to the lumber. I cut one of the ears off for the front wheel, leaving the other one, and drilled 2 holes in it and attached my steering. And it works out pretty well. Kind of a turnkey solution. I like it. It has bearings in the head, so it doesn't bind. It turns nice and smooth. It's actually adjustable height, so it helps getting in and out. You don't actually want to drive with it all the way up, but you can pull it up to help you get in and out so you can fit your knees underneath it. It's it's odd, but it worked. And I see no reason why it wouldn't work again. The steering linkage here is 5/16 rod ends and 5/16 fine thread shaft. I used right-hand threads. These are female, so it goes onto the threaded rod. I used right-hand thread on both of them just because it was cheaper. Again, this was a budget build. The better way to do it, which is at least more convenient, is to have right hand and left hand and use like a turnbuckle assembly in the middle. So all you have to do is break your stop nuts loose, your jam nuts loose. You can turn the middle, and you can tow that wheel in and out just by turning the center section. You don't have to disconnect either end. On this one, you do have to disconnect one end or the other, and then spin it and then bolt the whole thing back together. Less convenient, but cheaper. I don't like to use 1/4 inch like a lot of people do, just because when you're using the threaded rod, I don't think that 1/4 inch threaded rod is really strong enough. I think it has a tendency to bend. I feel a lot better about using 5/16. And I mean, there's no real downside to using something larger. I suppose it weighs a little more, but we're talking about a couple of ounces at max. I doubt it's even that. So 5/16 fine thread rod and the rod ends. Now the bushings on the front axle and let's point that down a bit. The bushings on the front axle, the rod ends, when we get to the spindle, a lot of the components of the spindle all came from McMaster Car. They're an industrial supply store. They have a really good app for your phone, and the prices are pretty cheap for most of the stuff. Where they get you though is the shipping. So, but it's like shipping for one box, and you can fit a lot of stuff in that box as long as it's fairly small stuff. If you're gonna try to buy a 3-foot piece of steel to use for the front axle from them, I don't know how that would affect the shipping. But they kept sending me boxes that were, I don't know, 6 by 4 by 10 inches long, and you could fit a lot of stuff in there. My boxes were almost always only maybe a 1/4 full. But so if you know what you need beforehand, you can put it all into one order. The shipping is going to be this pretty much a set cost anyway. You can really get your prices down by just buying everything all at once. Now, things like the fine thread nuts that I use, the castle nuts for the spindle, like on there, you had to buy a bag of 50 of them. Well, per piece, it's pretty cheap that way, but I don't need 50 of them. It actually came out cheaper for me to go to my local hardware store and buy these there because I only needed 2. So you kind of have to pick and choose how you use McMaster Car. And your shipping costs are going to vary depending upon where you are in the country too, I suppose. Their warehouse that ships to me is in Atlanta. That's only like 4 hours from here, so it's not so bad. So the shipping isn't terrible. But if you're going to use them wisely. Try to plan ahead so you get as much stuff in one order as possible. Because if you have to pay shipping twice, there goes a fair amount of your savings. Okay, the spindle. Now, the brake here, let's start with that. Well, if I'm going to do that, I need to back up a little bit more. Okay, the wheel. The brake matches the wheel. Okay. The wheel is off of a PY50 mini dirt bike. It's a 50cc small dirt bike for children. It is steel, welded together, pretty nice, drum brake. It's a little small. I went with this because it seemed the cheapest way to get the brakes and the wheel and everything inexpensively. So the brake is also for PY50. Yeah, it fits another one too, PW50 maybe, but whatever. Check the price sheet that I attached to the end of the previous video. I'll probably also attach at the end of this video. The wheels were about $56, $58. Again, check the price sheet on eBay a piece. The brakes were about $22 to $24 a piece. I don't really remember. Again, check the price sheet. It's on there. So the brakes fit the wheel. Okay. The brakes originally had a little nub on the back of them. I cut it off just so I could get it closer to the pivot, the kingpin here. The axle portion of the spindle is a 1/2 inch grade 8 fine thread bolt. I believe this one's 5 inches long. It ends up being a little longer than I actually needed because a fair amount of it sticks out, but I wasn't sure how all this was going to play out. So check your measurements. I believe this one's 5 inch. I could have easily gotten away with 4.5, possibly even 4 inch, but either way. So I cut the nub off just to move things over, and I had to bore it out because I believe this is like a 12 millimeter hole, and this is, of course, a 1/2 inch bolt. I drilled it out on the drill press, ran the bolt through, put a jam nut in there so it is pinched onto this portion of the spindle. Then the brake goes on, and then another jam nut to hold the brake on. All in all, it worked out fairly well. These brakes are probably adequate for racing. They're not great. Chances are they would get a little better if they got worn in a little more. These are just barely beginning to get worn in. You can see here it didn't contact very well. So as this shoe got wore in more and more of it would make contact, your brakes would get better. But in Electrathon, we try not to use brakes too much because any energy you dissipate into your brakes by heat, you then have to make up when you get back up to speed again. You only have so much battery. The brakes have a slot on the back. Right, there you go. I found that a bolt fits through there nicely to keep it from turning. So when you hit your brakes, of course, the whole thing wants to torque in reaction to that. That held it fairly well. Well, held it very well. It didn't move. It held it well. The main portion of the spindle is what is left of a 2-inch square tubing, 1/4 inch wall. It was 6 inches long. I bought it on eBay. I got a terrible deal. It was like $26 with shipping for 6 inches of 2-inch square tubing. If you can source it locally, you could probably do a lot better. Again, it was not a great deal. But from that 6-inch piece, I cut both sides for the spindles. The only thing I had left over was 2 pieces like this, which I could have used here because in order to get any sort of Ackerman angle on this, the right steering geometry, my steering needed to be set out here where this would not reach, so I had to bolt that on. And then I bolted on this other little piece that holds my brake cable to go up to the brake actuating lever up there. Again, welding makes things easier. The 1/2 inch bolt, fine thread, is fine. It held up, it's strong enough, and don't worry about that. What I don't like about it is the fact that it creates a bit of a loose fit on these bearings. These bearings are R8 bearings, so therefore a 1/2 inch shaft. This technically is not quite 1/2 inch. My preferred method, if you're going to make your own and if you're going to be able to weld, is to use a shoulder bolt. Kind of like this. This is the 3/8 one that is the kingpin for this. But if you got a 1/2 inch one, This shoulder tends to be about 2 thousandths larger in diameter than this, which makes it fit the bearing a whole lot better, a lot less slop in it. When I make my other cars, when I weld them, I like to use shoulder bolts. It's a better fit. So if you can, do that. If not, again, this is a viable option. It just puts a little more slop into the joint, and all that translates into slightly more tire wear as everything is able to move around. Those R8 bearings I mentioned earlier are the wrong OD to fit in here. So if we get real close, you can see I used the strap from a hose clamp, a worm drive hose clamp. I use that on both sides. You can barely see the one in here probably. A little bit of paint overspray in there, but it's in there too. It makes a really good shim, and it is cheap, and for some reason it was just the right thickness. So I used it. This one looks like it's not seated all the way. Well, it is. That's just as deep as it goes. That part sticking out did not interfere with the brake because of the jam nut that was in there. It all worked out pretty well. I recommend using a little bit of Loctite in there, and the serrations, whatever we're calling them in there, for the worm drive, take Loctite really well. It allows it to seep down in, holds the shim in, holds the bearing in very well. I also put, because if you notice the bearings seat kind of deep, on the outboard side, I put in a couple of washers that have a larger ID than this, just two of them stacked on top of each other, just to shim the bearing out a little further to get them farther apart. Of course, the wider apart the bearings are, the more stable it's going to be. If you had them right next to each other, there'd be a lot more room for slop. You spread them out, that gets reduced. So I did that as well. All in all, these wheels, they're workable. I painted them blue and the paint's chipping off. Don't worry about that. They were white when I got them. Someone pointed out to me that there's only so much rubber available on tires of this size. By the way, these tires are Ranch Squad. These are bicycle tires. They are not the tires that go on these wheels, but they do fit. These are 14-inch bicycle tires. They call for 60 psi. They're the highest pressure I could find in this size. I ran them at 80 psi all weekend without a problem. You can see after 126 competition miles, we are just now down to the cords, but they held up. 6 races total, 2 races a day, 3 days, they held up. And the steering probably wasn't, or the alignment probably wasn't spot on, but it was close. But I consider that to be pretty decent tire wear. But someone pointed out, as I was saying before, that in tires of this size, there's only so much rubber to go around. Every time you corner, you're wearing off a little bit of rubber. If you have a tire that's twice this diameter, I'm not going to do the math on this. You're not going to have twice the circumference. You're going to have more than that. But either way, you have more rubber available to you because there's more rubber on the circumference. That becomes a factor after a while. Now, if you are running on a really good surface, say it's fresh asphalt, the turns aren't real tight, you're not going to be going real fast, then these may work out fine for you. If you have a good supply of tires and you're not afraid to swap them out, this size may work out fine for you. Otherwise, you may want to go to a larger diameter. 20-inch bicycle wheels and tires are very popular in Electrathon. Finding good ones that offer good brakes, a lot of people like to go with bicycle disc brakes. That's what I use on my other car. That can be tricky. One of the options you can do is go with moped wheels that have a very similar drum brake to them, it would be a 16-inch moped wheel, but that would take a 20-inch bicycle tire. They're sized differently. Moped wheels are sized by the rim diameter. Bicycles do everything by the tire overall diameter. So a 20-inch bicycle wheel fits a 16-inch moped, a 20-inch bicycle tire fits a 16-inch moped wheel. That's neither here nor there for this build. These wheels worked out pretty well. They worked out fine for what I was doing, but long term, I question how many tires you're going to end up having to buy. Use your own judgment on that. again, about $57, $58 a piece for the wheels, about $20-something a piece for the brake, a bit of hardware from McMaster Car, but it worked out. So this just goes on here. That's it. I had a couple of washers in there as shims to take up a little bit of the space. It worked. It worked pretty well. You don't have to have a welder, as it turns out. One thing I should have mentioned about the axle. By the time I got done racing, or the time they got done racing, I did not drive it. By the time it was done racing, it appeared there may have been a slight bend in the ends, bending upward, like it was flexing. When I got back and measured it, I put a straight edge across it, I found that the ends had come up about 1/16 of an inch per side. Again, this is mild steel, 1/16 of an inch wall thickness. It's not very thick. It's what Home Depot had. If you have the option to go a little thicker, say 1/8 inch wall, you might want to. But again, we had people in this, our drivers were well above the 180-pound minimum for a driver weight. In Electrathon, if your driver does not weigh 180 pounds, they must carry ballast to make them reach 180 pounds. The drivers I used were probably minimum of 30 pounds over that, minimum. Probably more than that, but you know, let's not get insulting to them. So yes, it did bend slightly, just very slightly. So if you have the choice to go with something a little thicker, or if you had a better quality steel, again, mild steel from Home Depot is of questionable quality to begin with. You may want to do that. If you're going to have lightweight kids in there, and they have to be ballasted to 180 pounds anyway, chances are it would be fine. Again, we did not have failure. We just noticed that it did bend slightly. That's all.